Here we're going to name any similar figures, and we're going to justify our answers, and we'll just kind of talk about it a little bit here. But as we look at these things, the two things that are required for these to be similar figures is that the angles have to be identical, okay? The angles have to be identical because that tells us that the shapes are the same, okay? And then the sides have to be proportional. So as I compare the sides, I should get the same ratio when I compare each set of sides. So I look around and notice the little arcs that are through here, 3 arcs here and 3 arcs here, so those are the same. 1 arc here and 1 arc here, those are the same. 2 arcs and 2 arcs, those are the same. A right angle and a right angle, those are the same. And so as I went from angle to angle and compared them, just based on what's written here, yeah, all of the angles match up. So all the angles are congruent. So step 1 is done. All the angles check out. So angle check is done. So all the angles are the same. Okay, so that's the first piece of my justification. Check mark on that. Now I have to compare the sides. I have to look at this and say, hey, are the sides proportional? Do these ratios come out to the same thing? So like if I compare the sides, like the 6 and the 12, or the 12 and the 6, I could write the ratio and say, okay, that's 6 over 12, which is 2 over 1. But then I have to have the same thing for each of the other sides. So I would compare like these sides, the 24 and the 16. And so if I compare the 24 and the 16 as 24 over 16, well, that reduces to a 3 over 2. And notice right away, these are not the same. I didn't get the same ratio, which means these things are not proportional. I have to get the same ratio for every set of sides. So right away, these are not similar, okay? So no, these are not similar because I didn't get the same ratio for each. So not similar, okay? And I could keep checking like the 24 versus the 14 or the 6 versus the 6. If all of these give me the same ratio, then I can say that they're proportional. Then I can say that we have similar figures, but these ones don't. If I look at this one, once again, going through making sure the angles are the same, again, the number of arcs is an indication that they're the same. So 3 arcs and 3 arcs, same angle. 1 arc and 1 arc, same angle. 2 arcs and 2 arcs, same angle. Okay, so the angles all match up. Really, we just have to look at the sides and see, hey, do I have proportionality here? All right, do I get the same ratio when I compare each set of sides? So I could start with one of the sides and say, okay, how about the 15 and the 12? And again, last time I did big to small. This time I'll do small to big, 12 to 15. Ready? So 12 over 15, that's the ratio I get for the first set of sides. And of course, that reduces to a 4 over 5. So then I go to the next set of sides and say, okay, how about the 20 and the 16? And once again, I'm going to do small to big, so 16 compared to the 20. Oh, I guess I'll switch back to blue over here, right? 16 over 20. And of course, that reduces to a 4 over 5. And then I look at the next one and say, okay, let's compare these guys, the 8 and the 10. So once again, 8 over 10. I reduce the fraction. That reduces to a 4 over 5. And so what happens here, no matter which side I went to, I got the same ratio. That means that the sides are all proportional. Proportionality, being proportional just means I get the same ratio every time. That's what I get here, which means these are similar figures. And so there's a little extra added challenge here in terms of labeling these. I'm going to say triangle. I'm just going to call the first one, I guess, G-I-J. And I'm going to say similar to, well, now I have to match up the parts. Like G matched up with M, okay? I matched up with O, and J matched up with T. So I have to label it in a way that kind of matches up the corresponding pieces, okay?